By now, you have probably written a few programs where everything lives inside a single main.rs file. That's fine for small examples, but what happens when your code starts growing 200, 500, or even a few thousand lines? It quickly becomes a mess, right? We need a way to organize our code, to split it into smaller logical pieces that are easier to maintain and reuse. Hello everyone, welcome to the Learning Rust series. In this video, we'll be learning modules and crates in Rust. In Rust, a module is simply a way to group related functions, structs, enums, and constants together under one namespace. You can think of module like a folder inside your project. It helps organize your code just like folders organize files on your computer. Let's start simple. Inside the main file, we can define a module using the mod keyword. Here, we created a module named greetings. Inside this module, we created the sayHello function to print the greetings in the module. In the main function, we use this sayHello function from the greetings module. And this is the syntax where the function belongs to this module. You have seen similar syntax in the previous video as well. Program also runs fine and prints from the greetings module. Notice the pub keyword before the function. By default, everything inside a module is private. It cannot be accessed from outside. So if we remove pub and try to call it from main, Rust will throw an error saying the function is private. The pub keyword makes that function public, available for use from outside the module. Think of it as opening a door to the outside world. Now, when your code grows, it's better to move each module into its own file. Let's create another file in the src folder and name it greetings.rs. In this file, we'll have the sayHello function. We don't need this anymore here in the main file. If we write mod greetings inside main file, Rust looks for a file named greetings inside the src folder. Let's try that. And it works. This mod greetings line tells the compiler that a module named greetings exists. It then looks for a file called greetings.rs in the same directory. When we build the project, Rust automatically includes that file's code as part of the project. Now it may happen that the modules are not directly inside the src folder, but the related modules are grouped inside another folder. What if we want to group related modules inside a folder and not directly under src? Maybe you have a folder called util, which may contain multiple files like math.rs and string.rs. We'll create a math.rs for now. Let's add a function to add two numbers in the math.rs file. In the main function, when we previously wrote mod greetings, it looked for the file greetings.rs in the src folder. But now math.rs is not directly under src folder, but inside another folder named util. So we need to write mod util. But how it can refer to math.rs file? What happens is when Rust sees mod util in the main file, it looks for a file named util.rs or a folder named util that contains a mod.rs file. We don't have a file named util.rs. Instead, we have a folder named util. So all we need now is to create mod.rs file inside it. Now to make math.rs available to the outside world, all we need to write is pub mod math. Mod math is used to include the math file and pub is to make it accessible outside this folder. Let's do a recap to understand. We have a util folder created under src, inside which we have the math.rs containing a function to add two numbers. Now to use this function in the main.rs file, we need to import this util module. We know when Rust sees mod util, it looks for either a file called util.rs or it looks for a folder called util which contains a file called mod.rs. We have the second one, which is util folder. So we just created a mod.rs file inside it. Now since util is imported in main.rs, to expose the add function in the math.rs, we added the line pub mod math. That's it. The mod.rs file acts as the entry point for that folders module. This is how nested modules work. Now to use the add function, let's have a print statement. Println and call the add function by writing util. Inside that we need to use math, and inside math we'll use the add function. We'll pass two integers to add. Now let's run the program and it prints the sum correctly. As the project grows, you will notice that calling the function like this over and over again can get annoying. That's where the use keyword helps. It lets us bring a path into the scope, so we can call it directly. For this, we write after the mod util statement, use util math add. Now the add function is added into the scope of main file. So we don't need to write this whole line again. We just can use add, and it runs fine as well. We can also add alias to the function using as keyword. We just need to write add as sum. Then we can use sum in place of add. It will still behave the same way. If we want to include multiple functions from the math module, we can write the function names comma separated inside the curly braces. Say for example, we have a subtract function in the math module along with the add function. I'll copy paste it, change the name and make it minus. So to add this in main, we write comma subtract and enclose the whole with curly braces. Let's use this as well. Print subtract 10 minus 2. Now let's run it again. We get both added and subtracted values. If you want to import everything from a module, you can use a wildcard. So instead of all these in braces, we just write the asterisk symbol. Now whatever is inside math, everything is imported here. No need to mention anything specific. It runs fine as well. A word of caution. While wildcards can save typing, they can make code less readable, especially in large projects where names can clash. You saw I made sum back to add before running when using wildcard. It is generally better to import only what you need. In larger projects, modules might live inside multiple nested folders. You can import from any depth using the full path. Use, create, util, math, add. The keyword create represents the root of your project, basically your main package, which is the src folder in our case. If you are already inside a submodule and want to go up one level, you can use super instead of create. Now that we are comfortable with modules, let's talk about crates. It is another essential Rust concept. A crate is the unit of compilation and distribution in Rust. Every Rust project is actually a crate. There are two main types. Binary crate, it produces an executable like our main.rs, which we have been seeing throughout this series, and library crate produces a library that can be imported into other projects. Library is basically a set of related functions and other useful features which we can import in our code and use it based on our need. Modules live inside crates, and crates can depend on other crates. Imagine you want to split your project into multiple internal crates. Inside our workspace, we can create another library using cargo new mylib --lib. This --lib flag indicates that the project is meant to be a library and not an executable application. You can see this mylib folder is created inside the main project folder. The structure looks same as the normal project, but if you expand src, you can see a lib.rs file instead of a main.rs. So this creates a new crate with lib.rs. We don't need these at the moment, so we'll comment them, insert our function. Now to include this mylib crate in our project as a dependency, we first go to our project's cargo.toml file. We can add mylib as a dependency like this. Now we can use this in our main function, similar to what we have done before. Just replace the util with mylib. This will be treated like a library crate, and it runs fine as well. This crate we created is an internal one, but we can also have external crates, which are libraries published on crates.io. This is Rust's public package registry, where we can find libraries to import and use. We can also contribute, but let's focus on using it first. You can include them by adding it to your cargo.toml file, like rand equals 0.8. Rand is the official random number generation library in Rust, and 0.8 is the version of the crate we'll be using. Using it is same as what we have seen before. So in the main file, we'll use the RNG trait of rand. Let's get rid of everything we don't need. First, we'll initialize the generator. It must be mutable because generating a new random number changes the RNG's internal state. Now let's create a variable to store a random number. To generate, we write rng.genRange and pass the range between which the random number should be generated. I am keeping 1 to 10 inclusive. Finally, we'll print the random number. Let's see what happens if we run. It printed a number between 1 to 10. But is it really generating random? Let's test it by having a loop to generate a set of random numbers. We'll have 10 numbers. Copy these two lines inside the loop and we'll change the print statement to see the count. Now if we run, it worked. 10 lines printed and it seems pretty random. Great, so we have successfully used an external crate in our program. So to summarize, we learned what are modules, mod keyword to declare a module, and Rust will look for a file or folder matching that name. Pub keyword to make items accessible outside module, use keyword to bring items into scope, alias by using the keyword as, wildcard to import all, binary crates produce executable, library crate produce reusable libraries, use internal crate within a workspace, use external crate from crates.io. This video will be very useful for your journey with Rust, as you don't need to write every functionality by yourself, but you can leverage reusable libraries to create programs faster. With all that, I take your leave. Let me know your thoughts in the comments below. If you found this helpful, don't forget to subscribe so you don't miss the next one.